All right, good morning or afternoon, whenever you're watching this. This is week 10, statistics lesson 19.3, combinations and probability. All right, so for those of you who've made it this far, we're almost done with stats. Congratulations. Uh, we just have one final concept to cover, and next week, we're in week 10 right now. Week 11 will just be a makeup week, and I'll go into more details with that in the Google Classroom stream. So, with that in mind, um, what are we working on? So, the only vocabulary I really have for you guys this week, because we're going to use the basis of the last 2 weeks in order to do this, we're just going to focus on combinations, which is a selection of objects from a group in which order is unimportant. For example, if three letters are chosen from a group of letters A, B, C, and D, there are four different combinations. What I mean by that is there's four different ways that we can pick a three different letters from those four from the set of four, right? So again, we're using the vocabulary from the last 2 weeks, and we're using last week as a jumping off point, and this is the lesson that follows that. So let's see where we go. So, what is the combination formula and when do you need to use it? All right, so just give me a second to move this. All right. Um, the combination formula is a way for us to determine uh, different groups in order for us to find different possible combinations or find different groups. Unlike last week when we were doing permutations, where we were just kind of trying to figure out what the total possibilities of something were, here we're taking into a matter of the idea of groups, right? So this is going to be made apparent after the example. So the background of this example is that a restaurant has 8 different appetizers on the menu. They offer an appetizer sampler, which contains any three of the appetizers served in a single plate. How many different appetizer samplers can be created? By I should point out that when they say how many different appetizer samplers, they're referring to how many of them um, how many unique samplers. Order in which they are selected does not matter. Um, that is that's key to this because we're not taking order into account. Like we're not saying like we want specifically something to be first, second, or third. We're not doing that. We're just saying in any order. So if I have 8 different options, right? I can have options 1, 2, and 3. That can all be one sampler, right, out of the 8. I can also have them um, in a different order within the group. So, for example, I can start off with 2, 1, and then 3. That is a that is a different combination, right, as well. So we have to think of it in terms of that, right? Um, like I said, order doesn't necessarily matter in that regard. That whole thing is just treated as one combination, right? If order mattered, we'd be left with a lot more combinations possible, right? So with that in mind, the problem is asking us to find the number of samplers that are possible if order of the selection does not matter. So in this case, we need to figure out what our N and what our R is, because if you guys look here, we are using a new formula. Well, kind of new. It's the permutation formula just with a C instead of a P, and we have an extra variable which is R in front of the N minus R. That's really the only change to it from last week. So with that in mind, we still need to know what N is and what R is. Now N represents your total. So here the restaurant has 8 different appetizers on the menu. So in this problem, N would equal 8. The total amount possible is 8 because there's only 8 different items on the menu, right? So no matter what kind of group or no matter what kind of combination I make, I have to pick from those 8 options. That's why N is 8. R is the group that's desired, right? Remember, I'm making combinations of 3 each time. So my R represents how big I want that combination to be. We've already established that the sampler contains any 3 of the appetizers. Therefore, my R, my group that I want, is composed of 3 appetizers within each group, right? So with that in mind, I'm going to just plug in these numbers into the formula, right? So if you notice from the circle to the next part, I replaced the first n factorial with 8. So it became 8 factorial divided by r factorial, which happens to be 3 now. So that's 3 factorial, open parentheses, 8 minus 3, close parentheses, and the factorial on the outside. Now, as I said last week, that factorial on the outside um, doesn't get attached to a number until the end, right? So 8 minus 3 happens first, that's 5, and then the factorial comes in. So this becomes this, right? We have 8 factorial divided by 3 factorial times 5 factorial. Now, at this point, I'm showing you two different versions of it because in the next problem, I'm only going to show you one of those versions, the shorter version. But here what's going on is if I have a calculator function, like if I have an Android, what I can do is I can write 8 and then press the sign for factorial, divided, and then I'm going to have to put, like if I'm putting this into a calculator, this is how you would have to put it. You have to put, find 8, find the symbol for factorial, which is like an exclamation mark. If you don't know where it is on your Android phone, it should just be like, uh, they should have a symbol for it. Like either you have to turn the phone to the side or you have to swipe something. But wherever it gives you more options, there should be an exclamation point. Just put that next to it. It should show 8 with an exclamation point. Then you're going to hit the divided symbol. And then here's the important part, otherwise it won't work. Make sure you put parentheses, 3 factorial, and then 5 factorial. Don't put that they're multiplying. I tried it when they're multiplying, and it turns out because of PEMDAS, it actually changes the answer. So you need the parentheses like this. If you're going to put it this fraction right here into the calculator so that the calculator can calculate it for you, you'd have to put it in this way, and it'll give you the same answer. If you're like, I don't want to deal with all that, I want something simpler, or I don't understand what this means, right? Take a look at this because this is also the same thing. So 8 factorial, in case you missed it from last week, is really just 8 times every number that came before it. So that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All those numbers are the same thing as saying 8 factorial, which is why 8 factorial is the shortcut. I'm just expanding it so you guys know what's going on. The bottom, right, where it says 3 factorial is represented right here, right? That's 3 factorial, right? 3 times 2 times 1. And the other one, 5 factorial, are these. This whole thing is represented by 8 factorial. Now you know where all those numbers kind of just expanded into those. Okay, so why did I bother expanding them? Because I wanted to show you guys what that means, and because now it's a fraction, you can see that a lot of these numbers are going to cancel out. The 1, the 2, the 3, the 4, and the 5 cancel out. I don't have to worry about them. If the same number is on the top of the fraction in my numerator as in my denominator, they cancel out, right? They cancel out to 1, which means that the only thing I really have to worry about is 8 times 7 times 6, which is 336, divided by 3 times 2 times 1, which is just 6. So I take 336 and I divide that by 6, and I get 56 combinations possible. So remember, the problem was asking, find the number of samplers that are possible if the order of selection does not matter. Well, according to this formula, right, there are 56 possible combinations of sampler appetizers that can be served, right? A customer has an option if they want to try a sampler and try 3 random ones, they have 56 different possibilities that they could come up with. That's significant to know because that means that you have options. You have a lot of options, right? How many? Well, 56 in this case, but if we mess with the numbers, right? Even if they added just one more option on the menu, that would drastically change the number of possibilities or combinations in this case, right? Okay, so hopefully that made some sense. We're gonna move on to the slightly harder version, right? How to find probability using combination formula. That last one was just what is combination formula? Like how do we use that formula? we haven't found out how to figure out what probability is or how to figure out what it is, right? So going back to about 2 weeks ago, right? Um, I introduced what probability is. Probability is the chance of something happening, right? So right here I have this equation, right? You guys see this? This is really important because the problem is going to ask us for the probability of something, of an event happening. And in order for us to calculate the probability of an event happening, we need to take the chance of that event happening, right? And we have to divide that by the total probability possible, uh, the total chance that all the different uh, possibilities, right? We're dividing the chance of a specific event happening divided by the total amount of possibilities possible, right? Okay, so what does this have to do? Well, this is what we're ultimately trying to do. We're ultimately trying to figure out this fraction. Our final answer to this problem is going to be in this form. It's going to be in a fraction. Now, if you notice, I have an n and a d here, right? All that means is that just means numerator and denominator. The numerator means it's the top number of a fraction, and the denominator is a label for the bottom number of the fraction. That's it. I'm going to use those as a shorthand later on because you're going to see that we need to figure out and we need to use the combination formula to figure out the numerator. And then we're going to use a combination formula again, but this time with different numbers to figure out the denominator, the d value. And then at the end, we're going to just divide them, and that's going to be our final answer. That's what we're doing for this problem. Okay, so now let's actually look at the problem and look at what it's asking us so we can figure out what to do, right? Problem. There are 4 boys and 8 girls on a debate team. The coach randomly chooses 3 students to participate on the competition. What is the probability that the coach chooses all girls? I suppose I should say that this is what is the probability that the coach randomly chooses all girls. Because remember, if he was just gonna pick girls no matter what, it'd be 100% chance. But here he's randomly picking out students, right? So he has no control over who he's gonna pick. The only difference is there are more girls on the team than boys. So we have to actually figure out the different possibilities or different combinations, right? Okay, so the question I have below the circle, right, is how to find the numerator or the probability of a coach picking 3 girls from a total pool of 8 girls. Now, I'm just going to try to figure out what the numerator is first, the number on top of the fraction. And the way that I do that is I'm going to use the combination formula below. However, since I want to know the chance of an event happening, of a specific event happening, my specific event here is the coach picking 3 girls from a total of 8 girls. Because remember, there's only 8 girls in the class, right? There's 12 students in the class, but 4 of those students are boys. So we're not going to count them for the numerator part of this problem. So n is 8 here, and r is 3. Okay, that's where we got our 8 from, and that's where we got our 3 from. Okay, now we're going to plug those numbers into our combination formula. We end up with 8 factorial divided by 3 factorial times 8 minus 3 factorial. We end up with, and we reduce that to 8 factorial divided by 3 factorial times 5 factorial. Again, if you're trying to do this on your calculator, you're going to have to do it this way. 8 factorial divided by parentheses, 3 factorial times 5 factorial. Side note, if you guys are using a iPhone, you're going to want to turn your cell phone sideways, right? And when you turn your cell phone sideways, it'll give you a bunch of options. And factorials, I'm sure, will be somewhere there. However, for whatever reason, the iPhone calculators on cell phones, uh, they don't let you see the entire problem you're typing. They tend to solve it immediately as you put it in, right? So if you put 8 factorial, it'll give you a really big number. It won't say 8 factorial. It'll give you like whatever 8 factorial is, which is a really large number. Then you're gonna put divided by, and then you're gonna have to put the parentheses 3 factorial, 5 factorial. Don't put multiplication in between 3 factorial and 5 factorial, just put 3 factorial, 5 factorial, close parentheses, and see if that works. iPhones are a little tricky because they require a different method. If you don't know how to do that, then just use the method that we used here, right? Write them all out, expand it, cross them out, and then just do a simple multiplication across, okay? Well, anyways, just so you know, um, when you plug these in, you should get, uh, let's see, the probability is going to be, it's going to come out to 56, right? Sounds familiar, right? Because the previous one, it was the exact same thing, right? In the previous example. Well, we have 56 combinations, right? In this case, uh, what is the probability of a coach picking 3 girls from a total pool of 8 girls? Well, there's 56 combinations, right? 56 different possibilities or combination of girls that can be picked from the 8 girls, right? Okay, I have my numerator now. I need my denominator, right? Or the total possibilities. So the probability possible equals the combination of 3 students picked from a pool of 12 students. Remember, now the denominator includes the boys here, right? Because we're just asking what is the chance that he's going to pick 3 girls out of 12 now, right? So uh, so now it's asking what is the probability of picking 3 students out of 12, not girls specifically. But here our n is 12 and our r is 3. So now we're going to do the same thing. We're going to plug those in. We're going to replace n with 12 and we're going to place r with 3 everywhere in the formula. So you can see the formula down there. 12 factorial divided by 3 factorial times 9 factorial. Again, if you're putting this into a calculator that allows you to see the entire problem, you're going to want to put it like this. Okay, you're going to want to put it like that. And it should give you 220, right? So 220 is the denominator for the probability fraction, right? So now I have my numerator and I have my denominator, right? Notice here I have these now. And now I can put those two values together and I'm going to just divide them. Now all we need to do to finish our problem is we need to divide our two answers. So our original problem, what is the probability of the coach chooses 3 girls for the competition? Well, we have the total probability of coach picking 3 girls from the class and the total probability possible. That's my two answers from the previous steps that I did. So 56 divided by 220, I can simplify that, right? And I'm going to end up getting 14 out of 55, right? If you're wondering what I did to simplify them, right? What I meant, I just divided the top and the bottom by the same number, which happened to be 4. If you divide 56 by 4, you get 14. 220 divided by 4, you get 55. Okay, so if I told you, however, if I asked you, what's the chance that coach is going to randomly pick 3 girls out of the class to represent us in a debate competition, and I just looked at you and told you it's 14 out of 55, you look at me like I'm crazy, because that's not what am I supposed to do with those numbers, right? In reality, you're just supposed to divide them, which means 14 out of 55 is the correct answer. It is the correct fraction. But in the real world, we want things in percentages, which means we're going to have to convert that into a percent. So 14 divided by 55, if you put 14 first and you put divided by 55 in a calculator, what you ultimately get is a decimal. You get 0.25. Again, if I look at you and you ask me that question and I tell you 0.25, right? Maybe you might make the connection, maybe might not, but most people would still look at you like you're crazy. Why are you giving me a decimal? Move that decimal over 2 places to the right or multiply it by 100. Either way, you get the same answer, and it gives you a percent, right? This is your fraction, this is your decimal, and this is your percent. You want percents because percents are the easiest to understand. 25%. My final answer is there is a 25% probability that the coach will randomly pick 3 girls for the debate competition in a class made up of 4 boys and 8 girls. Okay. Yeah, so I hope that was helpful. Um, if you're having trouble, please join me for Zoom. This week for Zoom, I'm going to be doing Zoom on Tuesday and Thursday. If you need to talk to me on Monday and Wednesday, just send me an email and I will see what I can do. But office hours this week will be on Tuesday and Thursday, 1:30 to 3. Okay. With that in mind, homework and practice numbers 1 through 7, do 6, 7, 20. Only 7 problems. You guys are so close to finishing. Just 7 more problems and you're done. All right, guys. So keep your head up. Lots of crazy things happening this week, but just power through it and you'll be fine. See ya.